So now in this video, I'm just going to quickly do a demonstration of a NPN bipolar junction transistor. This is a 2N2222 wired as an inverting amplifier. So it is inverting because we're going to give it a weak signal with this trim pot. It also has a resistor in series with it because we don't need to give hardly any current. In fact, current is bad in this circuit. We just mostly need the voltage at the base of the transistor. And so with the trim pot, you turn it towards the positive rail and the voltage goes up. You turn it towards the negative rail, the voltage goes down. The signal that we get out of the transistor circuit, this is our load, couple LEDs, the signal will be the opposite. So we'll look at that now. This trim pot, there you can see voltage spikes. I didn't change anything. It comes loose from the board. And let's zoom in. It comes a little loose from the board, and so we get rapid voltage changes. I think it's the positive side there disconnects once in a while, and so when you give a lower voltage to the transistor base, then you get a higher voltage at the output. So we'll see that coming up. So let's do that one first. We keep getting voltage spikes going positive, so I'm going to press down on the trim pot, and hopefully it goes better. So we're going to turn the voltage negative at the trim pot. We're going towards the negative rail. As you can see, the voltage got higher at the output. Now we're going to turn it towards the positive rail, and now you can see that the voltage dropped at the output. So we're measuring one side of the LEDs. Other side of the LEDs is a voltage divider. So it's 2.5 volts there, and then now it's lower than 2.5 volts at the output, and I have the yellow LED to light up when the output is more negative than the voltage divider by about 2 volts. And then that's why it's dark in here. We're not dealing with much voltage. And so now I turn this towards the negative rail, and we already clipped. So I don't have to go all the way to the negative rail to get almost all the way to the 5 volts there. That's why it's an amplifier. So a little bit of wiggle right here results in a lot of voltage change. As you can see, the trim pot started coming loose. And I'll try to stop blocking the LEDs. But there you can see the LEDs light up as the voltage change. And as you can see, it gets to its limits about twice as fast as the trim pot does. So that's why it is inverted. I got to raise the voltage of the signal to get a lower voltage there. And if we had a 0 volt reference point, which we can do by yanking the jumper out here and putting it to the other side of the LEDs. So of course the only voltage change we'll see is what is across the LEDs, but now it's about 0. It can go lower than 0. So what we got to do is I already have this set. We can change voltage or press the button and change where our 0 volt point is. And let's go up to, we can speed this up by clicking that, and then things go faster when you turn the dial. So for more fine changes, you can do that. So right now it's below 0, and that's why the LED is on. So our 0 volt reference point is those two resistors right now, which is a big reason why current is limited. So in any case, now we're below the halfway point up there, 0 volts. Let's get this back here. And so I'm going to have to turn this towards the more negative rail to get the voltage to go up. At about halfway, we'll get to 0 there. And then going more negative, you can see the output goes more positive. So it's inverted, and the voltage change is moving faster than what the trim pot is. So it is amplified probably about 2 times, something like that. So that's the basic principle for the circuit. Let's zoom in and get a closer look how I wired it up. So to begin with, we have the trim pot, one side to the positive rail, the other to the negative. There's a resistive element there and a wiper that connects to that resistive element. And so when you turn it towards the positive rail, it's connected basically directly to the positive rail. There's a bunch of resistance to the negative rail that it starts ignoring because it's connected directly to the positive rail. As you turn it towards the negative rail, there's more resistance towards the positive side, less resistance towards the negative side, and so you get an output of a fraction of the power source voltage. And you get about halfway, you have about half of the power supply voltage. And as you go more negative, you keep getting a lower voltage. So we need that voltage, but not the current. If we go all the way to the positive rail, then the base 2 emitter will fully conduct other than this low value resistor, and that's bad. So we want the voltage but not current. So I have a 10 kilo ohm resistor here to help pass along the voltage and to limit current. So this is considered a higher impedance voltage source. And so in any case, as we saw, it tracked the voltage that we applied pretty readily. So that comes to the base of the transistor. So let's move this jumper to get a better view of what is going on with the transistor. So you can see here we have a resistor. This is the 2N2222. So looking at the flat side here, the bottom pin is the emitter, middle pin is the base, and the top pin here is the collector. And so the emitter has a 10 ohm resistor. It's a low value resistor, but it is enough to set the voltage within the component. The 100 ohm resistor is going to limit current because sometimes the transistor is conducting fully. And so this is a 5 volt power supply. This is a 100 ohm resistor. Sometimes it's going to be running at a 1/4 watt of power, just a tiny bit lower than that. And so we are maxing out this resistor. So it'd be better to use a couple of 50 ohm resistors in series, or a couple 200 ohm resistors in parallel, but to dissipate the power. But in any case, it is what it is. So we are at the max power here, so it'll be okay, but not ideal. That's when the transistor is fully conducting. So now, as I said before, that signal comes to the base, and then the resistor, it's a low value resistor, its main job is to make sure to set that voltage. The collector here, now that is where the output is. So when the transistor is not conducting, we have a low signal. Let's say we go all the way to the negative rail. That turns the transistor fully off. Then it becomes as if the transistor does not exist. Then, as far as the load is concerned, we have the 100 ohm resistor coming to the jumper there, and then since that's more positive, the red LED, the long lead, the anode, is connected to that jumper, with the yellow LED, the short lead, the cathode, is connected to that jumper there. So the yellow LED is going to block a lot more than 5 volts in that direction. It is reverse bias when the transistor is off. And so it comes to the red LED. Other side of the LED is a voltage divider. So just like with the trim pot, we have one resistor to the positive rail, 100 ohm resistor again, and a 100 ohm resistor to the negative rail. So that gives us 2.5 volts, equal resistance to each side of the power supply. With 2 resistors, we will get half of the power supply voltage. So about 2.5 volts there. So if we have 5 volts at this side, that is a 2.5 volt difference across the LED. Of course, it's going to start conducting and blocking some of that voltage. And that's why they're not getting very bright right now. We're not dealing with much voltage. So now let's go to the other extreme, and remember there's the halfway point in between. When both LEDs were off, we were somewhere close to about 2.5 volts at this point, somewhere close, because it takes a higher or lower voltage depending on which LED you're looking at by about 1.5 volts or so, 2 volts before they start conducting. And so in any case, when the yellow LED was on, that meant that we had less voltage at this point than that point right there. And the reason why was because, again, remember, this jumper is coming to the base of the transistor. If we turn the trim pot close enough to the negative rail, or to the positive rail I mean, then that goes to the base of the transistor positive, to the resistor to negative. It gets the transistor conducting. And when it's fully conducting, because that's the easiest to understand, you can think of the positive here coming to the collector, and then when the transistor is conducting, then it getting sucked down to the negative rail. And so this is a low value resistor, 10 ohms versus the 100 ohms. So we get a voltage really close to the negative rail through the transistor at this point here. And so the reason why the yellow LED conducts is because with 0 volts here, so it would be lower voltage there than what this resistor is providing, because it has more resistance than that 10 ohm resistor. We can get a positive signal over to here through the yellow LED and then to the negative rail, like that, when the transistor is fully conducting. And so it will get some of the current from that resistor, but also this resistor and the LED there. And so that's why it's not very bright. We are not dealing with much power here. We're wasting a lot of heat, a lot of power in the form of heat actually. But it's a demonstration circuit, so it demonstrates a lot of principles of electronics. It's not a practical circuit. You'll find more practical circuits, but hopefully this demonstration circuit makes those practical circuits more easy to understand. And as I said before, this jumper should be over here, and the other two jumpers we had were just the oscilloscope looking at the voltage difference between 2 points on the board. So hope that made sense. I wasn't sure if I was going to make a video on this circuit or not, and so I didn't prepare terribly well. And there's a lot of material on inverting amplifiers using the transistor, and to be honest, you'd probably be using an op amp or other integrated circuit intended for amplifying low signals. You won't be making them yourself, but it helps a lot to understand these principles when you're working with other circuits. So I think it's important to still build them and test them out. So thanks for watching. I will see you in the next video.